Happy Thursday to all of you. Today we're going to be talking about the formulas for exponential growth and decay and start breaking them down a little bit more now that we have some basic understanding. So our main formula for exponential growth and decay is f of x equals, well, we called it a when we talked about it in algebra terms, and that's our starting amount. How much do you have now? And then we're going to times that, we called it b, and that's our multiplier, and then to the x power. And the one thing we don't have here is this plus c. And again, we're not going to be worried about that part right now, but it's there, and it's what raises the graph up and down a little bit. All right, so what we're going to be working on today, the main idea of today's lesson, is we're going to be finding this multiplier number that goes here. All right, it's a number that gets the power of x. So if we're talking about exponential growth, and we know the growth rate as a percentage, then that multiplier becomes 1 plus the growth rate as a decimal. We have to convert the percent to a decimal. And we'll do some examples here in a moment. If we have exponential decay as a percentage, we want to take 1 and minus the percentage rate as a decimal. If we have our growth as a fraction, then we do 1 plus the fraction, or growth rate, our decay, as a fraction, we do 1 minus. Then there are always some special multipliers. If something has been tripled or doubled, we just use that number itself. We don't have to do the 1 plus or 1 minus portion. So let's find some multipliers. And again, that's all we're doing today is just this piece. Next time, we're going to start looking at the whole equation together and looking at some real-world examples. But first off, we just got to find this one part. It's where the work is. All right, so if I'm a multiplier, if I want to increase something by 12%, well, if it's increasing, that means I want to do 1 plus, and then that percentage as a decimal, 0.12. So to move or change a percent to a decimal, you move the decimal spot 2 places over. The decimal was here between the 12 and the percent sign. Move it 2 spaces left. All right, which would give us 1.12. Now, what if it's a decrease or decay? Something is decaying at 6.4%. Then we take 1 minus the decimal for 6.4%. So the decimal is between the 6 and the 4. Move it 2 places, filling empty spots in with zeros. So that's 0.064. Now you might have to use a calculator for some of these subtractions, unless you're really good with your decimals. And that's going to give us 0.936 as our multiplier. All right, well, what happens if we're doing fractions? We're going to increase by 1/5 of the original number. Well, that would be an increase, so 1 plus 1/5 equals, I'm going to put it as a decimal, 1.2. So that's 1 plus 0.2. 1/5 is 0.2. Well, if I'm decreasing, then I'm going to do 1 minus. So if I'm decreasing by 3/10 of the original number, I'll do 1 minus 3/10. And again, on a calculator, that's going to end up giving you 0.7. So what I'm hoping you see from this is that when it was growth, the multiplier was larger than 1 because you're adding to it. When it is decay, your multiplier is less than 1 because you're subtracting from 1. Then there's that weird one. 8 times as much means our multiplier is 8. No 1 plus or 1 minus. If it's one of those weird terms like double, triple, or 8 times as much, do exactly what it says, 8. It's just when we're talking percentages and fractions that we have to use that 1 plus and 1 minus. So this is what your work is today, is identifying these multiplier numbers from some basic situations. And then say next time we're going to start looking a little bit more at some real-world problems and going through both the multiplier and starting amount. We kind of skipped over that part today. We'll put the starting amount in next time and then combine these two into one. Again, look at this from a real-world situation. All right, let me know if you need any help with your work today. Good luck.